Hi, I'm Carlos. I work at GitHub. You might have heard of us. We provide hosting for anybody that wants to sign up. So we see a fair few edge cases. So let's see what happens. We're the largest Git hoster in the world, at least of the people who release numbers. Recently, we now have just over 59 million single repositories and about 21 million reusers. So we see our share of different use cases that people do. So I work in the Git infrastructure team. We're the ones who provide the Git to GitHub, both internally, so the website, the API, those send messages to our services, and we also support the external users. That's if you run a Git push or a Git fetch against GitHub, you're running against our services. And we do also serve as support escalation. So if support is unsure of what's happening or something is really wrong with a repository, they'll ping us and say, okay, I'll ask the team, and then that's us. So most of the time, this is just an unexpected use case. It's not people being malicious. It's just that we didn't expect to see what people are doing. Maybe people are being trying to hack the Git system and try and make it do something that it wasn't designed to do. That's usually fine. Sometimes that clashes a bit with what we expect to happen and how we build GitHub to behave. Sometimes the solution to this is social. We have to just tell the user how to best how they should be behaving, how we want them to instead structure the project, or maybe just don't do this, use a different feature. Sometimes it is just technical on our side or on their side. Sometimes they are trying to do something they think is the right thing, and sometimes that doesn't actually work out. So let's start with our own repository, GitHub. That's how we deploy GitHub. We use GitHub. So we deploy quite a lot, around 100 times a day. That's something we've spoken about previously, and we're very proud of this. This lets us be very agile. This lets us do tiny changes and test out to see what happens. But of course, that means that there are a lot of computers constantly asking the file servers, hey, give me the latest update. Right? So this is we have, I think nowadays it's closer to 1,000, but it's machines that are asking constantly for the updates between CI and then the deployment, which is more to about 600 machines actually running the app. So this is called a thundering herd, when a very large set of clients all ask at the same time. So we can use the fact that they were all at the old state, and they say, oh, give me from A to B. When we can detect that this is happening 600 times, and from the third one onwards, roughly, we can detect, oh, everyone's asking for the same thing. We're just going to store it on disk and serve it out. So for most of these deployments, we don't actually even need to speak to the file server that's actually hosting the repositories. We can cache it for a few minutes, and then that works out really well. So this is something we named Lariat. We wanted to open source it. It's sort of in process. There's lawyers involved. Hopefully we can get it out there. And yeah, I mean, caching is sort of the secret weapon we have here, right? Because this doesn't happen just to us. Many people will say, oh, every time someone commits on GitHub, I'm just gonna spawn 500 machines, and everyone's gonna perform a clone or an update. And this is something that even happens internally. So I've heard from on-prem customers that even internally, if your company is big enough, it's basically like providing a public service, because you have people who are 5 levels away from you, and you can't really tell them, please stop doing this, it's hurting the servers. Let's go over with Kubernetes, K8, Cube, I'm not sure how to pronounce it. They make extensive of pull requests, which is good, right? But we perform test merges every time that you update the pull request, but also whenever you update the master branch. So if you have the pull request page open, or if you're accessing the API, then we will say, oh, I don't know this anymore. The base branch changed, so I'm gonna test again, and that happens for 100 people. So that creates 100 jobs, 100 reference updates that we try to create. That causes a lot of contention because for now we're on a distributed storage system, so we need to perform a consensus on this is the actual update that happened. Right now we're still using three-phase commit because it's tested. We're working on getting a faster one, but for now we're relying on the one that we know actually works. So yeah, if we have 100 people watching a pull request, or 100 different pull requests, we will try and perform 200 reference updates because we try and perform the merge and we try and perform the rebase, so you can choose, and so that we can then immediately update the reference without having to run it again. This is something that causes a lot of friction at the update stage. And we have a couple of ways of solving this. One is we've begun grouping the updates on the producer side. We're working on collating them, or not collating, grouping them up on the consumer side. So whenever something is trying to create updates, it will see, it's someone else also trying to create a bunch of updates. Let me get them up. Because the issue we're facing is not the number of references, but the number of actual updates, which is where we need to perform the actual consensus. And of course, most of these are just robots, so it's okay if it fails. They don't care. They'll just try again. And this is what happens on the web page, right? You have a bunch of JavaScript that's asking, say, hey, can you get me an answer to this? Can I paint this green again? And if it fails, it'll just ask again. They don't care. You probably have the tab in the background from this morning and you didn't realize, because we all do that, right? So yeah, I mean, we have this pattern in a few other places. So when database updates from users, they get priority, and anything that runs in the background, they can just sit and wait and try again later. Usually, when people write in to say, is this okay if we do this? I don't know if it's too big. Usually, they think they're going to have a much bigger effect on GitHub than what they're actually going to do. Usually, we have big computers. It's usually fine. In rare cases, it is like, we do have to say, don't do this. This is not going to work out. And then usually they don't. They either use like for one typical thing is they'll store a bunch of the release tarballs, but they'll store them in the repository. We ask them, no, just use the releases feature because they'll actually go into a place where we expect to store files. In this case, though, they had this idea. I guess it's a fun idea. They called Commit Wars. There was this hackathon over a weekend. They wanted to have a raffle to win, so people could win a prize. There were about 300 people there. I said, okay, well, there is a cutoff date, so everyone try to push to this repository, and then the last person to push before this cutoff date wins the prize. When they asked us, so they were into support, which is, this is good. And then we said that this isn't going to work out for multiple reasons. Among them, that's not how Git works. You can just fake the date of your commits. So you should just put it and then just force push on top of everyone else and always say that you pushed just before the cutoff time. Also, 300 people constantly pushing, that's not going to work out well. So, we told them no, for these reasons, and they did it. They tried to perform 7,000 pushes in an hour. So that's what that looks like. The red line you can barely see at the bottom, that's our normal threshold for alerting. So that was fun. And I mean, all of these exceptions were just like, hey, there's contention on the logs. I can't perform all of these updates. It did only happen the once, so it wasn't too bad. I mean, if they had kept going on, we would just ban the repo, basically. But here, it failed exactly the right way. It failed how we thought it was gonna fail. That's how we knew how we had built our tools and the system, and this gave us a lot of confidence in to know that this is exactly how it behaved. This is how it should have behaved, and no one else was affected. Or maybe any other repo on that server was maybe slightly slow, but because of the unit is the repository, no one else had to wait in line to perform their updates. So this was just, we got alerted, but we were up and working anyway, so that was okay. Sometimes people do actually use GitHub as a database. It's not ideal because it doesn't expect to be used as a database, but it can be fine. So this repository was actually doing it well. They had a bunch of small directories with subdirectories and subdirectories, so that the data did shard fairly well. So it didn't have much of an issue. So there were 841,000 files, but it was okay because they were also in like 100 directories or so. However, they were trying to update the top-level README from the web view in the web editor in our website, which there's about 6 files in the root directory. So how hard can it be? Turns out, what we were doing here was the same that would happen locally, right? So when you run a clone, when you check out the directories, Git updates a file, the staging area, the index, and then when you run git add on the top-level README, it updates the file, the entry, and then writes it back out, and then you can create the next tree quickly. That bit we can do, however, we're on a server, we don't have a checkout, we don't have anything of the sort, so we had to read all of the 841,000 files into the README. That took a while. It actually ended up being over the 9-second timeout that we give ourselves for the RPC calls that do this. So the wrote in and said, hey, why is this failing? So we said, sorry, yeah, it turns out this is actually our problem. Just that we weren't expecting this kind of thing. This is where it's useful to have to graph everything. So these are the RPC call timings. You can clearly tell when I initially deployed the fix. Here, what really helps is a tool we have called Scientist, which lets us run 2 commands and compare the timings and the results. So they let me say, okay, well, my new code, is it going to work the same way as the old one? And I actually managed to find a place where our code was relying on an undocumented side effect of the way we were doing things. So it was good that I didn't just deploy the new method, otherwise 1% of all gists would have failed, that kind of thing. The improvement was severe enough that you can tell this, the first part of where the arrow points, that's actually running both of them. And it's this is linear percentile is averaged. So the new method was quick enough that it actually brought down the average, even though we're running it more times. So that was pretty cool. I was proud of that code, and this actually helps everyone. So it is sometimes really good to get all of these big customers, because then now everyone gets to use the faster code. I was looking through some of the repositories. This is something that sort of interacts with what we do, that not necessarily tell, but we sort of do it for the customers, except sometimes people like this repository show up. So apparently in NantGag people like it. It's a funny images site apparently, and they replaced their feed with an app, and it had ads, so people didn't like that. So people created their own feeds. So this person was pushing 300 to 400 megabytes every 10 minutes to the repository, and at least they were force pushing. So they only ever had 300 to 400 megabytes of reachable history. However, as a service, in case you have a link in an email or in an issue thread or whatever to a commit that you force pushed away, we keep them around, right? Because just in case you still need it, we don't want to break your links. Except, if you're pushing hundreds of megabytes, that adds up. So here we have tools so we can run this and say, okay, well, let's do an actual garbage collection run, and let's actually get rid of this. But we would have to keep running this every few days. So I mean, the issue here really is just please don't do it. And they stopped, so that was good. They're now hosting their images elsewhere. I'm not entirely sure why, but yeah. So sometimes it's just, hey, you shouldn't be doing this, right? And then it's fine. So you might have heard of this one, Cocoapods specs. It's a package manager for the Mac tools. They store their manifest on GitHub, and that's sort of how they update it. They do about 1,000 commits a week, roughly. And until recently, they had a single tree or directory with every single project name. That gets expensive because, as like I mentioned earlier, Git is not a database. It doesn't behave like a database. So we kept seeing this show up. And of course, not only is the issue with there's a lot of files, is that thousands of clients, and anytime you run Coco update or whatever you run to update the manifest, all of those people are just hitting our repositories, and those all get routed to the same computer, which will suffering a bit. And on top of that, we have quotas for how much CPU time you're allowed to use. There's a few buckets. So yeah, people were waiting longer and longer. So much so that they actually opened an issue saying, hey, this is really slow. Like Cocoapods is getting slower and slower. And it came up with like Hacker News or something. They contacted support because they went, hey, like our users are upset. And we're like, well, what did you expect? It was fine. We hadn't told them not to do it until then, right? So we basically just ignored it whenever it came up. Sometimes you'd have to say, oh, we'll run maintenance again because it took a while. So as a short-term fix, we spread the load among 3 servers, which is something we luckily built in for seeing such a thing. So GitHub is also another repository that we spread load over 3 computers. So we always write to 3 computers, but we generally read only from the one. In this case, we spread out the load onto 3, so you get 3 computers, which means you get 3 times the quotas. And then we also set up title limits on the displayed history because it turns out most of them were robots, just crawlers or just whatever. And we tried to be nice and display like, oh, this is the last time this directory was touched, all of these files were last touched in this commit, and then no human is actually really looking at this repository. So we set up tight terms on this. To add to this, what they were doing is to try and save download space. They were setting, this gets a bit into Git itself, but they were doing shallow clones and then updating naively, which meant that they were trying to save themselves space, but in such a way that we were not able to use the Lariat project I mentioned earlier. So whenever all these thousands of people wanted to update, we were completely unable to use the caching layer because it had extra information saying, oh, I want from A to B, except all of these other repositories. And in the end, they ended up downloading all of the data, but not being able to tell us that they were trying to download all of the data, making us unable to cache. So we told them, and then they fixed it. It took a while because it's a big project, but as I mentioned, then and then also the nested directories, because that helps Git. It can also Git can then reuse older objects to reference to the older versions of the trees, right? So won't get too much into how Git works there, but essentially, small directories work better. Just like you would organize your source code directory so that you don't have 50,000 files in a single directory because that, for one, looks messy. Git doesn't like that either. Yeah, sometimes people are trying to be helpful, and they are, sure, but then they do it in a way that sort of makes what assumptions we made a bit invalid. So Jekyll now is a repository to get started with Jekyll. This is the blogging or just static website creation tool that we have at GitHub. This is how you get GitHub pages out. So we'll host your blog or whatever. In this case, however, every fork of this repository is someone else's website. So there's basically no common content past the time that they fork. This means that all of the assumptions we make were, for a software project, you create a fork, you do a few updates, you send a pull request, they accept it or not. And that's it. Then all of this content stays together. We're not counting on multiple, possibly even years, of different blogs or separate web pages. So this one from time to time takes a while to actually finish running through maintenance. That's generally fine. The clones are a bit expensive because we have to keep each of the forks separate, so they're all fast. It also eats up a bit of disk space. That's generally fine, until a spider comes and asks for all of them at once. This is a 32-core machine with a load average of 400, which we got alerted to, what was happening because of the, file server level checks, saying, hey, this computer is a bit upset, like what's going on there? We discovered there were, 4 or 5 IP addresses that were trying all to access at the same time, and they had managed to, the way they had exactly done it, they had managed to sort of bypass slightly the quotas. So usually we wouldn't allow you to get to use up this much CPU, but because of the way they were requesting it, they actually managed to bypass that. So we figured there's no way this is a real request. Like there's no way 20 people in the same data center are all interested in all of them. So we just banned the IP address, and it went fine. So this was a purely technological fix, if you want to call it that. This repository name already made me think this is not going to be fun. So yeah, some people use it for logging. Does not usually end well. But this one's even more interesting because we figured out, okay, there's this repository always failing maintenance. It's sort of stuck in a maintenance loop. Like what's happening? So we contacted the users because this was a public repo, so we could actually look into it, to what was happening, and we saw that there was all of this constant pushing of about 3 different commits, all empty. So we're like, what is even happening? It's not even a CI log. It's just empty pushes. So we sent the owner an email. He writes back, says, yeah, no, we were trying something out, but we stopped 6 days ago. So we double checked, like, nope, it's still happening right now. Turns out they had forgotten to turn off one of the processes that was spawning other processes that were spawning other processes, and they were all pushing to GitHub, to this one repository. And it took about 6 days for it to get to the point where we actually noticed. So it's actually kind of impressive. But yeah, I mean, this one we just tell them, oh, could you double check? This was like an academic email address. I assume some student got a bit careless with the lab. Yeah, I mean, here what happens here, the reason we actually even managed to notice this is by pushing so often, they created a situation where we're running maintenance. Every X pushes, we run maintenance on a repository network. That's a repository and all of its forks. And we run it so that we collect all of the different updates that they've pushed to us, and we create a new, bigger back file. Essentially, we just sort of do what a database does and just hoover up all of the small changes. But they were pushing so often that by the time we were finished doing all of these changes, it's like, oh, there's already over n, what do you say, x, whatever. There's already over this many pushes, so let's do maintenance again. And that, it ended up causing so much load that we did notice. I don't know, I'm not sure there's a lesson to this, it's just, I thought it was funny. So, keep your repositories in check and keep your processes in check. We have a fair few popular repositories. So these are a few stand-ins for different kinds of popular repositories. So we have, each of them has a slightly different way in which they're, let's say, annoying or they're challenging. So for example, the Linux repository has 16,000 forks. Each of them is 1 gigabyte if you run git clone. We obviously don't spend 16 terabytes on it. If we did that for every repository, that would, we have 51 million of them. We just run out of this space. What we do instead is we deduplicate on the objects. So this maintenance process that I was talking about earlier, what it does is grabs data from all of the different forks, which we generally assume, except for the couple I mentioned, that are like 99% the same. So, so we hoover up all of this data, we package it all together from Delta, so it's small. And, for Torvalds Linux, instead of 16 terabytes, it's 42 gigabytes. So that's a neat improvement. That also it's bigger than if you did it sort of naively. We have this thing called Delta Islands, which is a thing that we have a blog post on on our engineering blog about it. If you want to read more about it, essentially it just means that for any fork, we take care that we're not accidentally mentioning an object that you wouldn't be getting. So you have to walk through through the whole Git graph, and it all gets a bit complicated. But in essence, that means that it's bigger than it absolutely has to, but it's more efficient. So we're doing it for you guys. We have the IntelliJ community repo is one that also keeps coming up. It's 3 gigabytes and 1.6 thousand forks. The main issue here isn't so much the amount of forks or even the size of the individual repo. It's 52 gigabytes, which is actually bigger than at a tenth of the forks is bigger than the Torvalds Linux. The thing they have is 45,000 tags, and every time you fork a repo, we copy over all of those 45,000 tags. Whether that's a good idea or not is a different story, but it's what we've always done. So here, what we're doing is storing 45,000 tags, roughly 1.6 thousand times. And here is where Git's formats get a bit iffy, because we use plain text files, because that's what Git does. And when Git reads them, it wants to parse them and store them in memory multiple times, because Git keeps spawning off processes. So, for example, when you're performing certain types of maintenance, we'll end up using 15 gigs of RAM. And if you do that a few times, we're going to kill the Git process because it's using up too much RAM. It actually became impossible to fork IntelliJ a few months back. We're slowly fixing it, but yeah. So the last one, Spoon Knife, is one we use for training, one we use for teaching Git and GitHub. So people fork it, do whatever nonsense change they want, and then they create a pull request. So this is 160 kilobytes, 88,000 forks, and uses up 9 gigabytes on actual disk. So the 160 kilobytes is for the root repo, so the Octocat Spoon Knife itself. But here you can see, yeah, we keep all of them together, and this one is a bit challenging to keep under control because of the amount of forks, which means is that a ton of directories on the file system. Here, basically, you always have to be looking at the what is the bottleneck, what is the thing that's stopping us from being better right now, and always be optimizing, always do small changes because they all add up. When you're working at scale, any tiny improvement in the way that you read a text file, the way you perform different updates, this all adds up. So here we're the last one. It's just a companion app to people trying to learn. Here we have a similar issue from Cocoapods, where we ended up having a lot of text, a lot of files, or of entries in a single directory. Here, they were storing individual authors as individual directories. So they had 26,000 entries in a single directory. Now that's going to make even your file system be upset. Git is even more so. Here we actually, again, just ended up saying, hey, just don't do it, because what they were doing is essentially a blogging application, except instead of everyone getting their own GitHub pages, which we will gladly host, they were creating them in such a way in the single repository so that they would get a green dot on the contribution graph that we show, which sort of makes me feel a bit conflicted about even having it. Which, because it leads to things like this, of the gamification of contribution. It was supposed to be keeping the people motivated in staying learning, because they were supposed to be blogging what they learned today. I don't know. Basically, we just asked them not to, because this was just so far beyond any use that we can envision as reasonable. They then also wrote a blog post about how they broke GitHub, which is, good for them, I guess. I mean, they did break their own tiny portion of GitHub. So quickly just, what do I take from all of these works? About a year's worth of just issues, right? People are going to surprise you, users are going to surprise you, and that's okay for the most part, because they're the ones who you should be working for, right? So even if this isn't the thing you'd be using it for, it's okay, as long as it all stays within reasonable limits. Like, hey, let's store several gigabytes of images. It's not a reasonable use of GitHub. And sometimes you just need to ask the people, hey, what are you doing? Like, is it okay if you do it slightly differently? People react usually well, and the people who are also often know, I shouldn't be doing this way. So when you reach out to them and ask them to stop, they know they've been caught, essentially, and they'll stop doing it. And yeah, there's always something new when you're working, when you let anyone push data to your system. Yeah, people are going to give you lots of data. All right, thanks. See me.